I really like Golang. I think it's cool, I think it's neat, it's cross-platform, it compiles to a full portable executable, and the syntax is nice. It's easy to read, easy to write, feels a little bit like Python, but it's still got all the memory safety and modern stuff alongside languages like Rust. But the syntax isn't as gross and horrific and make me hate myself, but you still get all that low-level power of using a language like C, but you're a little bit higher level in not C and in Golang. So it's awesome for architected software, full-blown production applications at scale, and a little bit of malware. In the cybersecurity space, Golang-based malware has been growing, on the rise, and there's been kind of a cat and mouse game of, doing some of the digital forensics, analysis, reverse engineering of Golang binaries, and the offense still trying to obfuscate, hide, and mask it in different ways. So in this video, I want to explore some of that landscape. And I'm going to drive a little all over the map here, but please stick with me. I think there's a lot of really cool stuff here. And if you like Go, it's just cool. So I am inside of my Windows 11 virtual machine, and I've just downloaded and installed the latest version of Go. At the time of recording, taking a look at go.dev online, the latest download on Windows is Go version 1.24.2. You can see I downloaded that just a moment ago. Now with Golang installed, let's say I want to start a new project. I'm going to put my hacker hat on, I'm going to act as the adversary and say, I'm going to write some new malware. Now, you might have your own opinions about using Golang for maldev or malware development, and that's totally fine. This is all just for education's sake. I want to do a demo, and forgive me, I know, a bit far-fetched, but just to showcase, if I were to start a new project, create a repository on GitHub, I'll literally name something, cheesy, haha, my new malware. I know I wouldn't leave that public, but I will just for easy command line work here. So let me copy and paste this URL and clone it down to create our own new little Golang app, or my new malware. Now in my Windows 11 virtual machine with Golang installed, let me open up a terminal for us to work in. I'll hit F11 to full screen this, make the text a little bit bigger for you to see, and I'll clone down that mynewmalware.git repository. With that, we can start to work. I will go mod init my new malware, and really it might be worthwhile to include the github.com/my name total opsec fail for my new malware, but you get the gist. Let me open up Sublime Text so I have a text editor to write some code in. Keeping it simple, let's just create a main.go file, and we'll create the package main. Let's import just a simple fmt for format. We can do some simple output. Let's create a main function, and let's do format, just little print line, hello world. And for a little bit of extra sauce, I think it would be fun to create just a little secret here that maybe we would want to hide or obfuscate. Create a sub package. We'll just call this secret.go, package secret. And let's define a secret function, haha, hee hee. Let's do another import format. I think we can just echo that out. Format.println. The secret passphrase is please subscribe. Haha, cutesy, dumb. Now we can add another import statement, and let's actually wrap these in the parentheses in that Go way to do things. And I know this is, again, the OPSEC fail that I'm intentionally running up against the wall for, so I can import my new malware and the secret all from the GitHub repository from my username. Haha. Actually, we want to expose that just as well, so that should be a capital function name, and then we can do secret.secret function, I think. Can I now build my malware? Okay, and now we're building it just fine. I've got now a mynewmalware.exe included here, but I actually really want to draw attention to some of the debug build info, like symbols, things that aren't stripped from the binary. While I could use go build with an output, we'll just call that debug.exe, and I'll also compile with some LD flags, so we could say tac S to remove symbols and tac W to clean something else up. Tac W is the removing dwarf debugging info. So let me now output that to like release.exe. Compile that. Now, if I have these in our directory, we have debug.exe and release.exe. Obviously, debug will do as it should, and release will do as it should. Now, I know that's a super small proof of concept, but it's the right idea, isn't it? Say you have some program, some code, whether it's malware or whatever, that you don't really want other individuals to track down what could be sensitive info, certain strings, certain command and control callbacks, whatever. An analyst or reverse engineer, okay, you want to try and hide that from them. But some of those reverse engineers or malware analysts will be using tools like Binary Ninja or IDA or Ghidra or other disassemblers and things that can help them determine what does the program do. So first things first, let's start with those three. Let's look at this thing debug and release in Binary Ninja, in IDA, and in Ghidra. Now we're gonna move quick and cruise through this because I don't think this is really where the fireworks are at. Let me open up Binary Ninja. Let's get to my new malware. And first, let's start with the debug executable. Oh, hang on just a second. Before we go any further, please let me take just a quick moment to tell you about the sponsor of today's video, Keeper Security. Managing privileged access is one of the toughest challenges in cybersecurity today. Every organization, even my own, needs a way to seamlessly secure and manage access to critical resources like credentials, servers, web apps, databases, and workloads. But it's tough with today's environments that have both legacy platforms and modern cloud infrastructure. That is where Keeper PAM comes in. I've had the chance to try it myself, and I gotta say, it's impressive. The platform is intuitive, powerful, and fits seamlessly into any tech stack. Keeper PAM gives you complete visibility, security, and control over every user and device in your organization. Whether you're working across multi-cloud environments, on-prem systems, or remote workloads, Keeper PAM has you covered. With features like passwordless access to all infrastructure, even machines that don't natively support it, just-in-time access, so you can grant time-limited access to resources without exposing credentials, automatic password rotation, you can just set it and forget it for ultimate peace of mind and protection of service accounts, and even session recording. You can track activity across SSH, RDP, database connections, and more. Whether it's managing privileged sessions, tunneling into SSH clients and database management tools, or securing multi-cloud environments, Keeper PAM just works. And when it comes to security, it's got everything you're looking for and more. They're FedRAMP and StateRAMP authorized, ISO certified, zero trust, zero knowledge, and the list keeps on going. So, if you're ready to secure your users, data, and infrastructure, check out Keeper PAM today with my link below in the video description, jh.live/keeper-pam. Huge thanks to Keeper for sponsoring this video. Now, when this thing opens up, Binary Ninja can already track down, okay, a lot of the symbols here, the stuff included in this is not going to be stripped or cleaned out. All of this is at least semi-readable for, okay, some analysis that you'll do. Obviously, being a compiled binary, it's not as easy to make sense of as like a scripting language, but you get to see this in action. If we take a look at these strings, can we simply track down our passphrase? Let me search for that. Looks like there's a big ASCII line here, but oh yeah, it does include the secret passphrase is please subscribe. That has not been stripped out. Let me open up what would be the release binary, letting this load. Binary Ninja, it's got about the subroutines now that it can't make sense of the names, at least immediately. Right? Let me say this is Binary Ninja version 4.2.6455, so I might not be on the latest release, and I know there are some other cool new plugins or extensions that have made a lot of the Golang work in Binja a lot easier. But let me take another quick look at these strings, search for passphrase again, just as our example. Okay, that still has it. Even in a release build, you can see the secret passphrase is here. It hasn't cleaned up any of those literal strings quite yet. Let's crack this thing open with IDA. How about that? Opening up my new malware. And first, let's take a look at the debug.exe. Yep, we can let this thing load. Okay, immediately, this has already tracked down a lot of the function names, even pertinent to, okay, the package, the library, the stuff that they are a part of. Now, if I search in the functions here, as I'm looking through this, we could probably even find, yep, our main.main. And taking a look at this, oh, we've got our hello world line here, and including the secret passphrase visible. Obviously, this is debug, so there's nothing strange with that. But let's take a look at release. Let's let IDA analyze it. Even the release build in IDA can pretty easily track down or make sense of, okay, these are Golang functions. This is built in the Golang language, and a lot of the internals or built-ins or things part of that for different things that that process typically includes can be noted and set as the names here. Last but certainly not least, let's take a look at Ghidra. Same process, just to get a quick look. Let's open up my new malware. Let's look at the debug.exe first. Now this already knows, hey, the language is Golang. It can track that down, and let's click OK to let it analyze. All right, now the Ghidra analyzer has already tracked down. If we're exploring in the functions, again, you can see stuff pertinent to different libraries, FMT, OS, etc. We could probably track down our main.main. Yep, and we're actually already looking at that thing. Decompiler makes a little bit of sense of it. All good. And I'm sure at this point you get the gist, but for sanity, let's go ahead and look at the release.exe. I'm not even letting this cruise through all of the analysis. I'm sure it can track down more and more information had we given it more time, but can Ghidra rip stuff out for the release build? Now, at least on my end, and again, I'm sure I could be missing things, but Ghidra up against the release build of the Golang binary can't as easily track down function names or other symbols. You can see they're all sort of renamed to fun as their function name, and it can't really determine what is our main package, main function, main setup, and structure. And you're probably already super familiar with those three, right? Binary Ninja, IDA, and Ghidra. In fact, we could even do like R2, Radare, or Cutter if we wanted to. But let me show you some other stuff specific to Golang binaries. The first one I want to showcase is Redress, a tool for analyzing stripped Golang binaries. You can track it down, I'll include a link below in the video description, but the Redress software is a tool for analyzing stripped Go binaries compiled with the Go compiler. It extracts data from the binary and uses it to reconstruct symbols and performs analysis. It essentially tries to redress a stripped binary. This one's cool because it has two operation modes. The first is acting on its own, a standalone where the binary is just ran, or you could actually run this from Radare 2 or R2 pipe. I'm not going to fall down the rabbit hole for R2 because we've already beat the dead horse with Binja, IDA, and Ghidra, but taking a look at Redress on its own, there's a lot of cool stuff that we can do with it. Let's pull down the code and see what it can track down for my new malware. I'll copy and paste the GitHub repository. Back in the command line, let me hop out of my new malware folder. Let's download Redress. Let's get in there, and then let's try to build this. Gentle reminder, I am still using the latest version of Go that I'm able to get pulled down, Go 1.2, 4.2, and it still works just fine. So now I could run redress.exe. Taking a look at this thing, it looks like it will need a command to run any of these, and obviously the binary that we'll take a look at. So let's start at the start. Let's go see what Go mod will tell us. So let me run redress.exe, Go mod, and our my new malware folder for first our debug.exe, not that interesting, right? Because that doesn't have anything stripped out of it, but obviously tracking down, okay, the name of the package there, the version in development for that build, but let's try this with the release build. Still tracks down the package, nothing fancy there. What else can we do with Redress? We've got info to print the summary information, module data, packages, and even a source code projection, as well as types. So let's do this all on the release build. Let's go for the types first and see what it tells us. Oh, it should be able to retrieve practically all of them. So let's run this with an all following that. And with that, oh, you need to actually tell it the version. Well, could we track it down with the info command? Let's use info. Okay, and this already sees OS, Windows, architecture, 64-bit. It includes the build ID, able to extract that out. Go root there. It even knows my path to the source code where I started to build this in, and the compilation flags like TAC-S and TAC-W. Let's try and get module data. Nope, can't track down the Go version again. We could probably provide that, but from the outside looking in, say we don't know the version, if we were just an analyst that found this file. How about packages? Only sees main in this case, because it's a small thing. FMT or the other imports not particularly tracking down. What will source do? Can it even see the source code? Oh, found main.go, lines 9 to 12. Not given any more details about that, though. How does this thing look with the debug build? Nah, same thing for like packages. How about module data on the debug build? So it's totally possible that I just missed it. Maybe it was in the output and I didn't see it, or I just don't know how to use Redress to track down the version of Golang that this thing was built in. But there is another tool that I wanted to add to our toolkit. I know we're up to an arsenal of like what, Binja, Ninja, like 5 tools at this point, but we'll fall down the rabbit hole just a little bit more. This is Go RESym. It's a Go symbol recovery tool that Mandiant put out some time ago, but but it's still maintained and still working okay. Go RESIM is very similar in the use case to pull down info about stripped Golang binaries. Now we can extract it, work with it, and we'll see what it spits out. Now I know this isn't hardcore code, disassembly stuff in the disassemblers and the other, debuggers stuff that we did previously, but this could still give us some interesting metadata or track down that sensitive information for command and control servers, sensitive configs, stuff potentially in malware. So let me go build a Go RESIM, and now we can run Go RESIM with my new malware in the release build, and they use some examples. TAC-T, this is in their usage section, so I do want to get this right. TAC-T will recover type names, user package names, standard Go package names with TAC-D, and input file paths TAC-P. TAC-D and TAC-P should be provided there, and this spits out a ton of JSON, but let me actually redirect that to Go RESIM symbols.json. Now over in Sublime Text, let's open that one up to take a look at that JSON a little bit better. Go RESIM symbols.json. Okay, cool. Take a look. This immediately is tracking down the version. Okay, that's Golang 1.24.2. Got the same build ID as we saw with redress. Architecture, OS, module metadata, etc. Okay, and now this is getting the path, GitHub. There it is, OPSEC fail, path included there. And please feel free to school me in the comments if I am missing some nuance, say the word. But look, this is already tracking down internal functions, at least a lot of the stuff that's included by default with Golang binaries. So that could be helpful for a lot of your analysis or reverse engineering. If we get to stuff specific to the binary, well, I know we have an extremely small, tiny proof of concept that just spits out OA, haha, secrets, something that we want to keep sensitive. Getting to the very end of this, it just sees main.main, but not our sub-secret little package that's included there. Can I search for that? No. Looking back at the README for Go RESIM, of course, there is more that you can do with this. A lot of it is going to be getting some of that metadata info out, just as we saw with redress. But let me put my hacker hat back on. Because if I were really making malware with Golang, I'd want to hide everything possible. I'd want the encryption. I'd want something to obfuscate the code structure, the code flow, all of this. So there are some tools that are already out there that do this. You might be familiar with Garble. This obfuscates Golang builds, or programs, binaries that you build with Golang. And you use Garble to try and hide, mask, and tuck away maybe any of those sensitive secrets or strings, literal constants in the binary, function names, packages, etc. This is cool because it wraps the Go toolchain. Now, this is funny. I think as I was getting ready to record this, it now requires Go 1.24 or later. I can see in the commits as of just a couple hours ago, there was a release that was like 30 minutes just before I started recording. Update to Go 1.24 and now dropping support for Go 1.23. So I was like, oh, is this still gonna work for a demo? But look, rather than using Go build, you use Garble build. This produces a binary that works just as well as a regular Golang program, but has as little information as possible about the original source code. In some cases, though, you can make this reversible if you want, but it makes it deterministic and reproducible, given the same initial source code. So while this is a cool, neat thing, let's talk about a little bit later how it could still be reversed or ungarbled. First, let's see Garble in action. Scrolling through the README just a little bit, they talk about the literal obfuscation that they do along with tiny mode that can kind of pack that in a little bit more, and they talk about a lot of the different transformations or things that they do to obfuscate this. We'll explore them soon, but first let's run it. So install is easy here. We can just go install Garble. Back at the command line, let's actually make another directory for us to work in. Let's create a Garble folder, and now let me install Garble. Now I can run the command Garble, nice and easy, and again, basically it is go build. It's replacing go build, and other things like go run, go test, etc. Of course, the commands to reverse it if you want to deobfuscate the output, if you could track it down, and the other options like literals, maybe tiny, and a seed value if you want to supply your own seed for a lot of the work that it will do. But let's Garble build my new malware. Let's use those other hardcore parameters like tac literals and I think tac tiny. Could I also add LD flags for the tac S and tac W to strip a lot of debug info? Oh, does that need to be over at the end, my new malware? Garble flags must precede commands. Okay, cool. So let's put build at the end there. Will that work? No, hang on. I think we need the LD flags. Wait, let me make this easy and just hop into that directory. So then we can garble build in the current directory just fine. Does that spit it out? Okay, that does. Cool. Now we have my new malware.exe, but let me actually move that so we can rename it to like garbled.exe. Of course, running garbled.exe has the exact same effect, but if we open this up in Binary Ninja, IDA, Ghidra, or Redress, or Go RESIM, what we see could be completely different. In fact, even just a simple strings test, like when we just ran strings within the other disassemblers previously, we could just as easily run strings on our old release build. Let me try to find string for passphrase. That should carve it out, right? Granted, there's a whole lot of stuff. Yeah, you can see it though. The secret passphrase is please subscribe, haha. Let me try to do that very same thing on our garbled binary. Let's find string, the passphrase. Now, because we've cleaned up all the literals, we're not gonna track anything down. Let's cruise through the Safari ride with Binary Ninja, IDA, and Ghidra, and look at how completely different things are with garbled.exe. Binary Ninja is still not quite tracking down what would be functions or subroutines that could be called here. If I toggle this to like sudo C, even if we tried to jump from the start to where we would follow through with the logic of beginning the program, it's tough to make sense of stuff. Let's try IDA. Remember, our release binary was working just fine to get a lot of the function names and symbols, but how about our garbled one? Load that, okay? Now, IDA struggles with this too. A lot of these are subroutines. You can see a couple, runtime right, things for different functions here, but not all of them are tracked down. A couple are, and maybe you can make some sense of this again with other plugins, again with extensions, but garbled is just one extra fence, extra bit of security and hiding and masking a lot of the inner code. I'll try not to drag us down the rabbit hole with Ghidra, but if I take a look at that one with our garbled binary, even when we try to analyze it, yep, you can do whatever you want, that's fine. It can still tell this is Golang, but if I try and analyze, now this takes a long time to analyze because, you know, Ghidra likes to take its time to chew through things, and Golang binaries are big chonkers. So look, functions here, again, not being able to carve out the names, not be able to determine what are packages or literal strings in this case. So Garble's doing what it should. But our security operations center analysts, malware reverse engineers folks, are we at a loss? No. Before I get to that though, we still need to knock down what would be the last two in our like set of 5 tools for analysis and see how it fares against our garbled binary. Remember, we were working with redress just a moment ago, so let's try redress on our my new malware and the garbled binary. Now we need to be able to tell it, okay, what do we want to learn? First, let's get the regular info, right? Well, it's all gone away. It only knows the operating system is built for Windows and the architecture is now AMD 64. Could we track down any of the Go mod details? No, nothing there. Are we still going to struggle with module data? Yeah, it needs a version there. How about packages? Well, that didn't give us a whole lot to start with, but it's worth exploring. Can't track down what would be a PCLN tab. A lot of the info that it uses. Types still aren't going to give us a lot of love. We needed a version for that. And source is probably not going to get us anything at this point. Yeah, no PCLN tab located again, which I think is where, hey, it could track down some specific information about Golang binaries. Well, how about Go RESIM? Let's change directory into that one. Let's use Go RESIM in this case on our garbled program with TAC-T, TAC-D, TAC-P. It spits some stuff out, but nothing particularly helpful. Let's redirect that to garbled symbols.json, and we'll open that in Sublime Text just as well. This is our old one, bear in mind, when we had just the release version, but now if it's garbled, let me go take a look at the garbled symbols.json. Let me put these side by side. I'll hit it's Shift-Alt-2 in Sublime Text, forgive me. Garbled symbols on the right now no longer tracks down the version, no longer gets the build ID. And if I scroll down to the very bottom where we got to see what would have been, okay, different packages, symbol names, things included here, taking a look on the garbled side of the house, it's all nonsense. You might be able to see the main function is the only thing that has, okay, a package there, but then the other things that would end up working with are not included. In fact, everything else, like internal or runtime or OS or stuff, they are just gobbledygook. Garbled info. So we get to the question, For analysis, for reverse engineering, for some of that malware understanding, are we screwed? Oh, before I leave here, I did want to note where you would have seen the build info, like the Go version and even the path and package info there, no longer present, right? If I'm scrolling down to see, that is not going to be included with a garbled binary. So are we SOL, or is the security cat and mouse game still going to help us advance and get a little bit more understanding of what could we be up against for Golang binaries? Now, finally, after all of that background context, I'm very sorry, this is what I actually wanted to make the video about. In fact, there will be more follow-on stuff after this if I haven't already made a mess. But look, take a look. Google Cloud and Mandiant put out GoString Ungarbler to deobfuscate strings in garbled Golang binaries. This is pretty recent. This was March that they put this out. And big shout out, big props to Chuang Dong. I'm sorry, I'm going to get the name wrong, but hey, incredible reverse engineering work here. In our day-to-day work, the Flare team, Flare being FireEye Labs' advanced reverse engineering team, they often encounter malware written in Go that's protected using Garble. While recent advancements in Go analysis from tools like IDA Pro have simplified the analysis process, Garble still hurts. It presents a unique set of challenges, including stripped binaries, function name handling, and encrypted strings. Garble string encryption, while relatively straightforward, hinders static analysis, so we have brought to life GoString Ungarbler, a command line tool written in Python that automatically decrypts strings found in these garble obfuscated binaries. So this is really cool. Here's how we can combat Garble. GoString Ungarbler is now available as an open source tool in Mandiant's GitHub repository. The tool only extracts strings for binaries where Garble is run with the flag -literals. This will help significantly speed up the analysis process for malware analysts when encountering samples obfuscated with Garble's literal transformations. Now, this is really cool. The whole blog and write-up goes through a lot of the internals, or how Garble particularly works, and its obfuscating compiler discusses a lot of the abstract syntax tree work done there, and a lot of the different transformations that you can see the source code dives into with stack transformation, seed transformation, split transformation. And I'll admit, I'm not going to drag us down the rabbit hole for all of this because they include a lot of back and forth. Oh, how does source code in Golang look when it's decompiled or disassembled? Taking a look at with other tools like IDA, like Binary Ninja, like Ghidra, etc., etc. A lot of scrolling, gonna skip past it, but let's see the tool in action. Of course, I'll include a link to the blog in the video description, but GoString Ungarbler is the easy button, which is awesome and helping, drive the industry further and cool stuff that they can do. So here it is on GitHub, a simple Python tool, super easy for us to work with. All we need to do is pull this thing down, but you could see an example in action, and let's see how well it does against our new malware. Note the dependencies here are Unicorn, Capstone, PE file, a lot of the stuff for disassembly work over in the Python world, but we can clone this down, pip install, and get in action. Back in the directory, let me git clone this down. I'll change directory into our GoString Ungarbler, and I am running Python 3.13 on this Windows VM. That command is py in this case, so I'll use pip through that with a module tac-m. With that, I can install tac-r requirements.txt in the given directory. It should pull down Unicorn, Capstone, all the stuff that we need for dependencies. Excellent. Now we can run Python GoString Ungarbler. We need tac-i for our input file. That should be our my new malware. And let's use the garbled binary. We'll use tac-o to put out a new ungarbled binary, which is pretty cool. And then tac-s to save all these strings that it's been able to extract and uncover. We can put that in like a strings dump.txt file. I'll hit enter here, and oh yeah, I just said we got to use py. Does that work? Yeah, okay, cool, it's cutting through it. Excellent. Do we have the passphrase at the end? We do. Take a look at that. That's super cool. The secret passphrase is, please subscribe, all extracted out of our garbled binary. Back in Sublime Text, let's go take a look. If we move up the directory, let's go to our GoString Ungarbler folder. Let's take a look at our strings dump. But this is, just Golang strings. I don't really know what more you want to see. That, of course, though, this is where maybe there's some sensitive, malware configs, maybe some API tokens, Telegram bot, little things, whatever, command and control data, or secret info that Garble has tried to tuck away. And now if we have what is the ungarbled binary, why not open that in Binary Ninja, IDA, Ghidra, etc. Taking another quick look at the README, I thought this was really interesting because they note, hey, the features here currently supporting Windows and Linux binaries obfuscated with garble given whatever version, and the Go versions that are pertinent, Go v1.21 to v1.23. However, if you remember early in the video, I saw, whoa, breaking news, they are just adding new features to garble and supporting only Go version 1.24. But ungarble in this case, or Go string ungarbler, seems to work just fine still. More to read if you're interested. Again, I'll include all the links in the video description, but this is awesome. I probably don't need to show you, but obviously now running string, simple and easy on our ungarbled.exe does have that all present, and we could do the same test as we did earlier, trying to search for our sensitive secret string, and the given passphrase tracks it down a-okay. Last couple of things I want to ramble about. Big shout out, big thanks to the folks that were able to, hey, add to a lot of the development of Go String Ungarbler, and a big shout out to OA Labs, or Open Analysis Live, Open Analysis Labs. They had some humongous, ginormous document on Golang garble string decryption. This is a 235-minute read, so I'm not gonna do that for the video, but looking through all this, I think a lot of it, if you are trying to scroll down, gets into some of the code that they're cutting up, and a lot of the strings in the mix here, which is a lot of the dump. If looking at the vertical scroll bar here, that's a lot of the page. Very cool, very awesome, but you know, tough to put in a video. At the very end, though, they do note another utility, gobfuscate, or go obfuscate, a different kind of go obfuscator, a lot like garble, that does kind of similar stuff we're tinkering with if you're interested. Another one that I want to give a hat tip to, ungarble, deobfuscating Golang with Binary Ninja. I believe this also came out in March from a lot of the Binary Ninja folks. They're discussing this exact problem and scenario, and they're talking about other malware samples that they've kind of cut across and seen this, and they walk through a very similar demo that I have, where you're looking at garbled code in Binary Ninja and seeing how that would have changed. But they have now put together a little plugin or extension, I think, that can help ungarble this all within Binary Ninja. So I'm scrolling through a lot of this, forgive me, but if you get to the very bottom here, they've implemented all the research into a new Binary Ninja plugin called Ungarble. Seeing it in action, you can just like sort of double click on some component here, and then it will be able to carve out everything for all of the other memory addresses or subroutines or functions and things that were then tucked away, now accessible to you. Super cool. Another hat tip, they covered this in a live stream and also got to chat about it in the Off by One security show, so sweet stuff. But take a look. The acknowledgement here is really interesting. Big shout out to OA Labs, but they were taking a look at this from Bandit Stealer, another info stealer out and about. Also, big shout out to Michael Gorlick, who wrote a garbled deobfuscator for IDA that ends up, and they use it just as that case study for the analysis of a Ransom Hub ransomware variant. And then, of course, sweet hat tip to the blog on Garble and that Go String Ungarbler tool we just saw in action. Wanted to give that as just another reference for you if you are using Binary Ninja. And yet another awesome thing that came out from the community was over from Velexity. They put out Go Resolver using control flow graph similarity to deobfuscate Golang binaries automatically. And this was April this year, so very, very recent. And again, similar thing, whole new approach, really cool stuff, up against Garble. In this case, they have a lot of dependencies. Some of the existing code tools that they reference, of course, Go RESIM that we've showcased, but what they do for the control flow graph approach uses some of the other tool chain stuff that they have previously. Go Resolver, Go Grapher, Go Strap, and Git Tool Fetcher. So awesome to see just a family of tools doing all this, and then really put into action with just a simple pip tool to cut it up. Also provides plugins for IDA Pro and Ghidra. So look, we've got all our bases covered, and they were doing this with some similar malware sample like style stuff. Really cool to see that in action. Does the very same. All right, goodness gracious. I know I fell down the rabbit hole here, but I hope that was pretty cool, right? Look, I don't know, did we cover like 5, 6 tools in this video? Chatting about Binary Ninja, IDA Pro, Ghidra, maybe a little bit of R2 in there. Oh, redress, oh, Go RESIM, Garble, Go Unresolver, Go Resolver, Go String Ungarbler. Wild ride, safari ride. Thanks so much for sticking with me. Hey, if you made it to the end, do me a favor, let me know. Please leave a comment with strictly the word garble. or like gobbledygook. I don't know. It'd be sweet to know how many of you really stuck out to the end with me. I know we were like surface level on some of the tools, but I think at the core, just knowing that these things even exist and that you can use them, and these are the things that are in your toolkit whenever you are up against a Golang binary, I hope that's awesome. I hope it adds to your arsenal. Thanks so much for watching this video. Hey, please do all those YouTube algorithm things, like, comment, subscribe. Please do give some love to our sponsors. There's a link in the video description. And with that, I've been talking for too long, man. Thanks so much for watching. I'll see you in the next video.